Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Hello, this is North American Math Contest Go Go Go. Last week, we have calculated about limit calculation at infinity and continuous, and the basic limit calculation. So this week, we are going to talk about the start of derivative. Okay, so we call it average rates of change and instantaneous rates of change. Instantaneous. Okay, so average rate of change is very easy to be explained. It's just the average change, the average rate of change, the rate of change on average for y at a given range. So this is average rate of change. Instantaneous rate of change is a bit complex. You choose a group. It's just the change of y respect to x at a given point. Like the instantaneous change rate of change at x equals to 5. So it is like compared to average rate, instantaneous rate of change is more specific at one point. Okay, so average change, it has a formula of this. A plus h. On graph, if you want to calculate the average of rate of change between here and here, this place is a plus h. This is a. So the distance between them is h. Okay, so you can now just think about this. Fa plus h minus Fa divided by h. So it's more likely like this on graph. While on instantaneous rate of change is more similar, but you need one more thing, which is this. So this is instantaneous rate of change, and without it, this is average rate of change. Okay, so let's give a problem. It requires us to let's calculate this. We are given a function, this. Average change at 1, 3. How are we going to calculate this? F3, or we can think as this, 1 plus 2 minus F1 divides by 2, given the formula of average rate of change. So F3 is equals to 16, F1 is equals to 8, divided by 2 is 4. So the average rate of change is 4. Now, what is the instantaneous rate of change? The instantaneous rate of change. Let's list out the formula, which is lim h to 0 Fa plus h minus Fa. Okay. Okay. So the instantaneous rate of change, if we want to find that x equals to 2, so we get f2 plus h minus f2 divided by h. So we just plug in 2 plus h square minus 11 divided by h. So we can try to think this as equal to h squared minus 4h plus 4 minus 11 divided by h. So it is now equals to h squared times 4h divided by 7. Well, sorry, there should be a 7 there too. Sorry, so there should be a 7 at this place. Minus 11. So it is equals to h squared plus 4h divided by h. So it is equals to h plus 4. And the limit for h is 0, and we plug in h is 0, so we get that the instantaneous rate of change is also 4. Wait, how should the instantaneous rate be same as average rate of change? Okay, don't care about it, it's just luck. So we know that the instantaneous rate of change and the average rate of change are surprisingly same in this case. So we are next going to do is we are going to find the equation of the tangent line at x equals to 4. For this problem, if you meet this type of problem, you need to remember that m in this case is the instantaneous rate slope. So according to the problem I said before, the instantaneous rate of change is 4. So we know that we only need to get xy and yy. So in this case, you just plug 4 into x1 and calculate this directly into here. And you get the result is 23. So the formula will be equals to this. X minus 4. Okay, here, this is going to be the equation. So we have done the instantaneous rate of change and average rate of change. We are then going to talk about the derivative. The derivative, it will have the same definition of this. The definition of derivative, we can say that it is just the same as instantaneous rate of change, which means the instantaneous rate of change, it will call a same, instantaneous rate of change and the derivative, they mean the same. So the derivative, this is just this fa plus h minus fa divided by h. This is derivative. Okay, here we end the calculus for this week. I hope you learn things in this chapter, and see you next week. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!